Hello everyone, this is Teacher Justina and welcome back to my channel. And if you are still new, then do not forget to subscribe, like, and share for more videos. Our lesson for this video is all about product of sum in difference of two terms. This is still special products. So let us explore. So again, this is product of sum in difference of two terms. So as you have given the model, we have uh, we have x plus y and the x minus y. And when we say sum in difference, so we have a sum, a difference of two terms. So how to get the product of these two sets of binomial? So let us try explore. So you are given x plus y times x minus y. So as you still remember, if we are going to FOIL them to get the product, how to find the product using the FOIL method. And please do observe uh, because if FOIL is something which is a long process, then uh, a certain uh, a certain pattern can be discovered out of the given process using the FOIL method. So first, using the FOIL, first by first, of course, we have the product of x squared. O refers to the outer terms. So the x and the y are the two outer terms, and it will gives us negative xy. The two inner terms, the x and y, so that is positive xy. And the two last terms, the y and the negative y, will gives us negative y squared. And for that, I'm sure that you have in mind that the negative xy and the positive xy are similar terms, thus we can combine them. So if we're able to combine them, they have both 1 as our numerical coefficient, and then they have opposite signs, so we simply subtract, and that will give us a 0. So to finalize, the remaining terms are x squared minus y squared. Let us proceed another example. We have there m minus n times m plus n. Okay, I just want you to take a look to each of the set. So each set have the same first and have the same last, but they differs in signs. So again, multiplying the two first terms as we have the FOIL method, we were able to get m squared, followed by the two outer terms, m times positive n. It will gives us positive mn. The two inner terms, the negative n in m, can be still written in negative mn. And the two last terms are negative n times positive n. That will gives us a negative n squared. And then again, we have positive mn and negative mn. In this case, we can combine them and it will gives us a 0. So again, the remaining terms or our product is already m squared minus n squared. Okay, so let us try have the steps in finding the product of the sum in difference of two terms. Okay, so what are the different steps in finding the product of the sum in difference of two terms? So when we say sum in difference, the first set of binomial or one of the sets of the two binomials is a sum and the other set is a difference. So a plus and a minus. So therefore, what is step 1? Step 1 is you need to check if their first terms are exactly the same as well as their second terms. So as we have seen, x and x are the same, the second terms y and y are the same. Next is you have to check if the operations of the two sets are exactly opposite. So you try check if they are exactly opposite. Otherwise, we cannot obtain two terms in the product, and then we cannot obtain a minus as the middle sign or the middle operation of the two terms in the product. So again, step 2, check if the operations of the two sets are exactly opposite. Are they addition and subtraction? So we have number 1, x plus y and x minus y. They are exactly opposite. While number 2, we have m minus n and we have m plus n. So we are done checking. Thus, since we have now step 3, if both steps 1 and 2 are done, then just square the first term. Again, just square the first term minus the square of the last terms. Again, see to it if the first terms are the same, the second terms are the same, and then if their signs are exactly opposite, this one, the negative and the positive, then we simply get the product by just multiplying directly the first and the first. We have their x squared. Then the second and the second, we have there the y squared. And in here, we have m times m. Both the first and first, we simply get the m squared. And then the second and the second will be multiplied. Thus, we get the negative n squared. And they have both negative. Okay, so let us familiarize. What do you call the product? What do you call the expression of the product of the sum in difference of two terms? So let us try this. So the x plus y and the x minus y. So the x plus y stands for the sum because it is a plus. The second set is a difference. Why it's difference? Because it's minus. So when we say sum in difference, and then how do we get the product? Again, as what we have the steps, see to it that the first terms are the same as well as the second terms. And then are they of opposite signs? Okay, so if that's the case, do not apply anymore the FOIL method but simply multiply directly both first and both seconds and express it in a difference. When we say difference, it should be minus. Okay? The sum, the product of the sum in difference of two terms is what we call difference of two squares. What do you mean by difference of two squares? So when we say difference, we have minus of two squares. Where are the two squares? So we have the first square and we have the second square. So the two squares is coming from squaring the first term and squaring the last term. And since the expression or the product is called difference, so there's no instance na their middle operation will be a plus because it's difference of two squares. So let us proceed to an example. You are given 2m plus 3 and 2m minus 3. This time we just simply apply the steps directly, no more foil. First thing, you need to check if the first terms are exactly the same. 2m and 2m, correct? The same. The 3 and 3, they are exactly the same. Do they differ in the operation? Yes. So they differ in the operation. So we simply multiply 2m times 2m. So that will be squaring the first term. Our first term is 2m squaring the last term, which is 3, and it is always expressed in a difference. So, but we are not yet done because we still have to simplify the 2m quantity to the power of 2. Applying the laws of exponents, the 2 will be distributed. Thus, it will become 4m squared minus 9. So again, is this the difference of 2 square? Yes, difference. So again, difference, yes. Are they squares? Are they perfect square? Yes, because 4 is a perfect square. M squared is a perfect square because a 2 as an exponent of the variable is exactly divisible by 2. So therefore, this is a perfect square, while 9 is still a square, a perfect square because 9 is coming from as 3 times 3. Okay, let's proceed to example number 2. So checking them uh, if they follows the steps, first term first term 3c are equal or are the same, the 2d and the positive 2d are same, are they in opposite signs? Yes, and therefore we simply do it this way and simplify this further, distribute the 2 so that will become 9. Okay, so 9c squared already minus 4d squared because 2 squared is 4 and d to the power of 2 is d squared. Okay, and let's proceed to example number 3. Okay, so let us try check. Are they exactly the same? Yes, 4w and the 4w, yes, exactly the same. Do they differ in sign? Yes, so let's proceed. Writing the first term and squaring the first term, square the second term, which is 4w squared. To further simplify, we have the 2 will be distributed, so h to the 4, then c to the 6, and then minus, then 4 to the power of 2, it gives us a 16, and then w squared. Okay, so let us proceed this next example. So as you have seen, our two sets of binomial has first term 2 cube kf squared, and then on the other set it has 2/3 kf to the power of 2, while our second term is 2s cube, and then the other binomial set has 2s to the power of 3. And then for that, we know that they are of opposite sign. We have a positive and negative. Thus, uh, we simply have this one. We square the first term, and then we square the last term. And for that, squaring the first term, which is 2/3, okay, 2/3 to the power of 2 means 2/3 times 2/3. And then k has a power of 1. Then there is a power of 2 outside. Then that will become 1 times 2 equals 2. And then f to the power of 2 to the power of 2 will have f to the power of 4. And then our second term is 2s cubed quantity to the power of 2. So this means that we will be having a 4s to the power of 6 because we multiply the inner and the outer exponent. And since it will always gives us a difference of 2 squares. So to finally, we are to multiply both numerator 2 times 2 and 3 times 3 as our denominator. Thus, our final product is 4 over 9 k to the power of 2 f to the 4 minus 4s to the power of 6. Then let us proceed number 5. Okay, so to check before squaring the first and squaring the last, then let us try have so far they are exactly the same. And then our last term, we have 3/5 and we have 3/5 and we have a plus and a minus. Thus, we will be having the square of our first term minus the square of our last term. And this means that 1/4 square, that means 1/4 times 1/4. And then the m has a power of 3 times 2. That will gives us m to the 6 and then v to the power of 2. Then the 3/5 to the power of 2, that means 3/5 times 3/5, and then of course it is always a minus. So therefore, what is 1/4 times 1/4? Then that is 1 over 16 m to the 6 v to the power of 2 minus 9 over 25. So therefore, we have this our final answer. Guys, I hope you have learned something from my video, and I hope you keep on watching, and do not forget to subscribe for more video updates. This has been Teacher Justina, and thank you for watching, and God bless us all.